Hello, I'm Colin from We Learn to Share, and today's lecture is about covalent bonding. This chapter is associated with chapter 6, but it's a lot easier. It is important to solve problems yourselves and get used to the techniques introduced. Among the bonds, covalent bonds hold nonmetal atoms to one another. Actually, we use a certain quantity and compare it to some values to determine the name of the bond, but in this chapter, we won't be that specific. These bonds consist of an electron pair shared between two atoms. The electrons may be located at any point around the nuclei, and the bonding electrons are more likely to exist between the two nuclei. These will be described further when learning about molecular orbitals. According to Lewis, who first suggested the idea of the covalent bonds, nonmetal atoms, by sharing electrons to form an electron pair bond, can acquire a stable noble gas structure. Let's take hydrogen for example. The pair of electrons in the covalent bond can be considered to occupy the 1s orbital of both hydrogen, and each of them can have the electron configuration 1s2, or the helium's noble gas structure. This idea of the noble gas can be extended to the bonds in molecules formed by nonmetal atoms. Valence electrons in its outermost principal energy level can be marked as a dot around the symbol of an element. And we can use these to show the bond between the atoms in a way that each atom has the noble gas electron configuration. Any kind of structure marked with the similar symbols are called Lewis structures. A pair of electrons shared between two atoms is a covalent bond, and they can be shown as a straight line between bonded atoms. If more than two pairs of electrons are shared, such as in a double bond or triple bond, parallel lines in number of the bond order can be used to represent the bond. The electrons not used on the bond, or the unshared electron pair, can be shown as a pair of dots on the atom. Atoms in covalently bonded species tend to have noble gas electronic structures, and this is called the octet rule. The hydrogen atom is exceptional, and these atoms tend to have two valence electrons. In particular, to draw a Lewis structure, we have to go through the sequence of these procedures. First, we have to draw a skeleton of the structures and indicate the locations of atoms using single bonds. Second, we should count the number of valence electrons. Third, we should count the number of these valence electrons that are available for distribution. Lastly, we should count the number of electrons required to fill out an octet for each atom in the skeleton. Here, since the number of available electrons is different than the needed electrons, we can modify the skeleton by adding a double bond. This way, the AE equals to NE, and we can write the formula by filling out the electrons to make sure that the atoms satisfy the octet rule. In some cases, two or more Lewis structures can exist for a substance. Our primary solution is using the formal charge, or the difference between the number of valence electrons in a free atom and the electrons assigned to that atom in the Lewis structure. To be specific, we can calculate the formal charge in the equation. After calculating the formal charge, we can use it in the determination of the Lewis structure, because the molecules tend to be in the form in which the formal charge is as close to zero as possible, and the negative charge is located at the most strongly electronegative atom. In some cases, the Lewis structure does not adequately reflect the properties of a substance, or it may be impossible to determine the Lewis structure. Here, with the understanding that the two structure is the intermediate between them, we can define the resonance form, in which the actual structure is called the resonance hybrid. Resonances can occur in molecular substances such as acid SO2 or organic molecules like C6H6. You must be careful because when multiple resonance forms exist, it does not mean that the molecules actually shift from one form to another. Second, Resonance forms can differ only in the distribution of electrons, and the arrangement of atoms or the structure of the skeleton cannot change. Some species of the atoms can be an exception to the octet rule. The molecules containing an odd number of valence electrons are one of them. In these cases, it is impossible to write Lewis structures. For example, in NO, we conclude the Lewis structure as this form, where N does not satisfy the octet. Some central atoms of molecular species may violate the octet too. For example, in the BeF2 and BF3 molecule, Be and B does not have 8 electrons around them, but experiments prove that this is the actual structure. Oppositely, some central atoms may have the number of electrons that exceeds 8. In this case, we can apply the expanded octet in which the extra pairs of the electrons are all distributed to the central atom. This is possible because there are leftover orbitals inside the valence electron shell of the atom. Now, before we end the lecture, we'll talk briefly about the molecular geometry. In a molecule with a number of atoms more than 3, we can define the bond angle and can consider this in geometry. In a triatomic molecule, we can determine whether the molecule is linear or bent due to this angle. The other geometries of an atom can be predicted by using the valence shell electron pair repulsion or the VSEPR theory. We can know the ideal geometry of an atom. First of all, in an atom whose central atom does not have an unshared electron pair, according to the number of atoms surrounding the central atom, we can predict the molecular geometry of an atom as in this table. Determining the molecular geometry may become more complicated. The molecular geometry of the bond and unshared electron pair number of 3, 4, 5, and 6 can be further divided into these geometric structures. The bond order does not affect the structure significantly, and the multiple bonds are considered to behave as a single bond. This is the end of today's lecture. Next time, we'll continue learning Chapter 7, so make sure you subscribe to the channel, leave a like, and turn on the notifications.